Everything that we've done so far has pretty much been a review of algebra. So now let's move on to some calculus. What's going to be of interest here is how do I take the derivative of this log function, and how do I integrate this log function if possible, and how do I work with the antiderivative as well. So first of all, let's go ahead and recall from previous sections. The derivative with respect to x of e to the u is just e to the u, u prime. E to the u, u prime. Also, we know that the integral of e to the u du, and these are so lovely because they're so simple, the integral of e to the u du is e to the u plus, of course, your constant of integration. So we've looked at these before. Let's go ahead and look at some new ones using our logarithms. First of all, the derivative with respect to x of the natural log of u is equal to 1 over u, u prime. Okay. Now if you want to verify this, you can use from our previous section in inverses, we had that, the derivative of the inverse function theorem that we looked at, and that's how this is derived. We can also look at the antiderivative of 1 over u, u prime. So how do I integrate 1 over u, u prime, or 1 over u du, and I get natural log absolute value of u plus c. You have to have the absolute value sign here, or the brackets around u, because of our domain restrictions and whatnot that we work with. I have one other question. What about just integrating the natural log of u du? And the answer is not yet. We can't do anything with this yet, but pretty soon we'll be able to use a technique called integration by parts on this in order to integrate it. But for now, we can't really do much with this. So these are our formulas we're using. If you're interested in deriving any of them, look back into that derivative of an inverse function from the previous section, and you can derive this natural log, derivative of the natural log of u, and of course from there you take the antiderivative. Let's go ahead and look at a couple of examples using these two derivatives. Okay, for our first derivative, we're going to take the derivative of the natural log quantity x squared plus 1 raised to the 4th power. Now we have a couple different ways we could work this. First of all, we could use our rules of exponents, or we could just go ahead and go from our derivative rule. So let's recall from right up here up above, the derivative of the natural log of u is 1 over u, u prime. So for down here, that would look like 1 over u times the derivative of u, which is x squared plus 1, the derivative of x squared plus 1 to the 4th. Of course, we're not done with this yet because I haven't actually taken the derivative. The derivative of x squared plus 1 quantity to the 4th, I bring the 4 down. This is going to be a chain rule. I decrease my exponent by 1, and I multiply it by the derivative within. So there's my 1 over u, u prime. Let's go ahead and rewrite this a little bit. It looks like I have a 4 times 2x, which would give me 8x, x squared plus 1 cubed, all over x squared plus 1 to the 4th. And of course we see simplification coming into play here. This will cancel, and I'll be left with 8x over x squared plus 1. And that's my solution. That's the derivative. Now this is the slope of the tangent line at any point along the curve. I could use this to try and find some slope charts, take another derivative for concavity charts, etc. But that is the derivative. Now let's go ahead and look at the same problem, just a different approach. So same problem, different approach. Let's simplify this first. X squared plus 1 to the 4th. So we want to not take the derivative, but simplify. The way I'm going to simplify this is by bringing the 4 out front, using my rules, and then taking the derivative. So drag the 4 along, it's just a constant, and the derivative of the natural log of u now, my u is just x squared plus 1. It used to be x squared plus 1 to the 4th, now it's just x squared plus 1. So my derivative is 1 over u times the derivative of u. 1 over u, u prime. Then of course we can simplify. And the derivative of x squared is 2x. Combining like terms, I get 8x over x squared plus 1. So if you note, I get the same answer either way here, but I kind of think this simplification, the second way we did it, was a little bit better. But it's up to you. You can choose whichever way you want as long as you show your work. Okay, for this next one, we're going to integrate x squared divided through by x cubed plus 1. Now, one important thing to remember is you cannot separate the denominator. So this does not equal x squared over x cubed plus x squared over 1, or some variation on that. Also, it does not equal x squared over x cubed plus 1, and then try and do some sort of strange canceling here. You can only cancel factors, you can't cancel terms. So I can't do that. These won't work, so I'm going to have to use something else. So I can't simplify this algebraically at all. So how am I going to work this one? Well, I think this will work pretty slick if we use a U-substitution. So let's let u equal the denominator, x cubed plus 1, and du is going to equal 3x squared dx, which I have the more complicated part. I have the x squared, so really all I need to do is to multiply by a 3 on the inside to go with that x squared dx. And of course, if you multiply by a 3 on the inside, you have to compensate with a 1/3 on the outside. So rewriting, I get 1/3 integral. Now let's see what I have here. This piece right here, 3x squared dx, is all du. So that's going to be my du. Now this entire denominator, x cubed plus 1, is my u. So from up above, we know the integral of 1 over u du is natural log absolute value of u, but of course we drag along the 1/3, natural log absolute value of u. My original was in terms of x, and so should my solution be. So I replace u, of course, with x cubed plus 1 plus c, my constant of integration. So that's my solution. Now, here's a quick question. Does this check? Well, remember, we can take the solution for an integral and take its derivative. And if I take the derivative, I better get the integrand back. So for here, the derivative of a constant, of course, is 0, so that's kind of an easy part. For this piece, the derivative of the natural log of u is 1 over u prime, and the derivative of x cubed plus 1 is 3x squared. Okay, so let's see if anything will cancel here. The 3's cancel, and I'm left with x squared over x cubed plus 1, which is the integrand. So I get exactly back what I started with, so this does check, and I do have the correct solution. I guess that's a really big check, and it is the correct solution.